Okay, we'll start with question number 1 of exercise 13.1 of limits and derivatives. That is, first question is limit tends to 3 of x plus 3. Fairly simple question. Direct substitution, 3 plus 3 is equal to 6. Question number 2, limit x tends to pi of x minus 22 by 7. So again that substitution, that is 22 by 7 minus 22 by 7 is equal to 0. Question number 3, limit r tends to 1 pi r square. Direct substitution is pi into 1 square is nothing but. Question number 4, limit x tends to 4x plus 3 divided by x minus 2. Direct substitution, 4 into 4 plus 3 divided by 4 minus 2, that is nothing but 19 by 2. Question number 5, we have limit x tends to minus 1 of x to the power 10 plus x to the power 5 plus 1 whole divided by x minus 1. So that substitution, minus 1 to the power 10 plus minus 1 to the power 5 plus 1 whole divided by minus 1 minus 1, nothing but minus 1 by. Question number 6, limit x tends to 0 plus 1 whole to the power 5 minus 1 divided by x. So if we directly substitute the value for x, we'll get 0 by 0. So we'll substitute x plus 1 is equal to y. So this means that if x is tending to 0, y will be tending to 1. Okay, and the value of x is nothing but x is equal to y minus 1. We put this limit y tends to 1, y to the power of 5 minus 1 divided by y minus 1. Okay, this is given by the formula limit x tends to a, x to the power n minus a to the power n divided by x minus a. This is nothing but n a to the power n minus 1. So here we'll have 5 into 1 to the power 5 minus 1, that is nothing but 5. Question, limit x tends to 2, 3x square minus x minus 10 divided by x square minus 4. So if we substitute, we'll get 0 by 0. So we'll have limit x tends to 2. If we factorize the numerator, we'll have 3x plus 5 into x minus 2 divided by, if we factorize denominator, we'll have x plus 2 into x minus 2. So x minus 2 and x minus 2 in the numerator and denominator gets cancelled, and if we substitute the value of x, that is 2, we'll have 3 into 2 plus 5 divided by 2 plus 2 is nothing but by 4. So now question number 8, limit tends to 3, x to the power 4 minus 81 divided by 2x square minus 5x minus 3. So this, again, if we substitute the value for x, we'll get 0 by 0. Now we'll have to factorize the numerator or the denominator. So if we factorize the numerator, we'll have x plus 9 into x plus 3 into x minus 3 whole divided by 2x plus 1 into x minus 3. X minus 3 gets cancelled. If we substitute the value for x, we'll have 3 plus 9 into 3 plus 3 divided by 2 into 3 plus 1 is nothing but 18 divided by 7. So question 9. Limit x tending to c ax plus b divide cx plus 1. So direct substitution, a into 0 plus b divided by c into 0 plus 1, nothing but b. So we'll have question 10. Limit z tends to 1, z to the power 1 by 3 minus 1 whole divided by z to the power 1 by 6 minus 1. So we'll divide. If we substitute the value for z, again we'll get 0 by 0. So now we'll divide numerator and denominator by z minus 1. So z to the power 1 by 3 minus 1 divided by z minus 1 whole divided by z to the power 1 by 6 minus 1 whole divided by z minus 1. So again, this is in a standard form, so we can directly apply the formula, that is 1 by 3 into 1 to the power 1 by 3 minus 1 whole divided by 1 by 6 into 1 to the power 1 by 6 minus 1. So this is nothing but 6 by 3, that is nothing but 2. Question 11. Limit x tends to 1, ax square plus bx plus c whole divided by cx square plus bx plus a. So if we substitute, and also they have given that a plus b plus c is not equal to 0. Again, direct substitution, will have a plus b plus c in the numerator and a plus b plus c in the denominator, which is that all these terms get cancelled, will have 1. So question number 12. Limit x tends to minus 2, 1 by x plus 1 by 2 whole divided by x plus 2. So now if we directly substitute the value for x, we'll have 0 by 0. To circumvent that, we'll have we'll add the numerator, we'll have x plus 2 divided by 2x whole divided by x plus 2. These two gets cancelled. What is remaining here is limit tends to minus 2 of 1 by 2x, that is nothing but minus 1 by 4. Okay, question number 13. Limit x tend to 0, sine ax divided by bx. So if we directly substitute, we'll have 0 by 0. So now what we'll do is limit x tend to 0, sine ax divided by ax into ax divided by bx. What we have done is we have multiplied and divided by ax. So here x and x get cancelled. So sin x divided by ax will be tending to 1, and what is remaining here is a by b. Okay, next up we have question number 14, that is limit x tends to 0, sin ax divided by sin bx, given that a and b is not equal to 0. So if we directly substitute this, we'll have 0 by 0, that is a given, and limit x to 0, sine of ax divided by ax into ax divided by sine bx divided by bx into bx. So this is nothing but, so this term and this term will be equal to 1. So what is remaining here is, and x gets cancelled, what is remaining, a by b. So and then question number 15, we have limit x tends to pi sine of pi minus x divided by pi into minus x. So if we substitute pi, we'll have 0 by 0 form. To negate that, we'll substitute pi minus x is equal to y. So changing the limit from x to y, we'll have limit y tends to, if we put pi here, we'll have pi minus pi, that is 0. Y tends to 0, sine of pi minus x is y divided by pi into y. So this whole term will be 1. What is remaining here is 1 by pi. So next one is limit x tends to 0 cos x divided by pi minus x. So if we substitute 0, we'll have cos 0 in the numerator and pi minus 0. Cos 0 is 1 and denominator will have pi. And then question number 17. Limit x tends to 0 cos 2x minus 1 divided by cos x minus 1. So if we substitute 0, we'll have 0 by 0 form. So we know the identity cos 2x is equal to 1 minus 2 sine square x. We'll substitute this in the equation. We'll have limit x tends to 0 1 minus 2 sine square x minus 1 by cos x minus 1. Then this will be equal to limit x tends to 0 minus 2 sine square x divided by cos x minus 1. So we'll convert sine to cos. What we'll have is limit x tends to 0 minus 2 of 1 minus cos square x whole divided by cos x minus 1. So if we send negative inside the bracket, we'll have limit x tends to 0 2 into cos square x minus 1 divided by cos x minus 1. So now if we factorize the numerator, we'll have limit tends to 0 2 into cos x plus 1 into cos x minus 1 whole divided by cos x minus 1. So this gets cancelled. What is remaining here is, we can directly substitute the value for x. What is 2 into cos 0 plus 1. So cos 0 is 1, 1 plus 1 2, 2 into 2 is 4. Now question number 18. That is limit x tends to 0 ax plus x cos x divided by b sine x. So if we substitute x is 0, we'll have 0 by 0. So to substitute this, to simplify this, limit x tends to 0, we'll take x common in the numerator. We'll have a plus cos x divided by b sine x. We can send this x to the denominator of the denominator. We'll have limit x tends to 0 a plus cos x divided by b sine x divided by x. This will be equal to 1. So what is remaining here is a plus cos 0 divided by b, that is a plus 1 by b. So now question 19. Limit x tends to 0 x secant x is what? So if we substitute, we'll have 0 into 0. So to simplify this, limit x tends to 0, x divided by cos x. So now if we substitute, we'll get 0 in the numerator and 1 in the denominator, that is nothing but 0. Question number 20. Limit x tends to 0, sine ax plus bx all divided by ax plus sine bx. Given that a, b and a plus b not equal to 0. So if we directly substitute this, we'll have 0 by 0. So to simplify this, we have we shall take x common in numerator and denominator. So limit x tends to 0. If we take x common, we'll have sine of ax divided by x plus b all divided by x of a sine bx divided by x. So x and x will be cancelled. We'll have limit x tends to 0, sine ax divided by ax into a plus b divided by a plus sine bx divided by bx into b. So this term will be equal to 1 and this term will be equal to 1. So what is remaining here is a plus b in the numerator. Similarly, we will have a plus b in the denominator. A plus b and a plus b, since this is not equal to 0, we can cancel this off. We'll have 1 as the answer. So now question number 21. Limit x tends to 0, cosecant x minus cot of x. So now if we simplify this, we'll have limit x tends to 0, 1 sine x minus cos x divided by sine x, and this will be equal to limit x tends to 0 of 1 minus cos x divided by sine x. So now if we divide denominator by x, we'll have limit x tends to 0, 1 cos x divided by x all divided by sine x by x. So the denominator will be equal to 1 and the numerator will be equal to 0. Therefore the limit will be equal to 0. And then we'll have question number 22 is limit x tends to pi by 2 tan 2x divided by x minus pi by 2. If we substitute the value of x as pi by 2, we'll have 0 by 0 form. So to simplify this, we shall substitute x minus pi by 2 as x minus pi by 2 as y. X is tending to pi by 2, y will be tending to pi by 2 minus pi by 2 will be 0. Okay, and what will be the value of x? Value of x will be equal to y plus pi by 2. So if we substitute all of this, the equation will be equal to limit y tends to 0, tan 2 of y plus pi by 2 whole divided by y. So if we send 2 inside the bracket, we'll have limit y tends 0, tan of y plus pi divided by y. So pi plus some angle, that it means that this tan will be in third quadrant. So we know that tan is positive in third quadrant, there won't be any sign change. So limit y tends to 0, tan of y tan of 2y divided by y. So we have limit y tends to 0 sine 2y divided by y into 1 by cos y. So if we multiply and divide by 2, we'll have 2 into and 2. So we have this whole value will be equal to 1. So we'll have, if we substitute y is equal to 0, we have 2 divided by cos 0 is 1. So the answer is 2. Then question 23. Limit. So we have f of x is given by 2x plus 3 and 3 into x plus 1. So this is if x is less than or equal to 0, and this is if x is greater than 0. We have to find limit x tends to 0 of f of x. So this exists if LHL is equal to RHL. So let's find out left hand limit. Left hand limit is given by limit x tends to 0 minus of f of x. So that is nothing but if x approaches 0 from the left hand side, we'll have to use this equation, that is limit x tends to 0 of 2x plus 3. That will be equal to, if we substitute x is equal to 0, we'll have 3 as the left hand limit. So the right hand limit, if x approaches, x limit x tends to 0 plus of f of x. So if x is approaching 0 from the right hand side, then we will be using this equation, that will be limit x tending to 0 of 3 of x plus 1. So that substitution will have 3. So since LHL is equal to RHL, limit x tends to 0 of f of x is equal to LHL, that is equal to RHL, that is equal to 3. And then question number 24. If f of x is given as x square minus 1, if x is less than or equal to 1, and minus x square minus if x is greater than 1. So we'll have to find limit x tends to 1 of f of x. So again we'll have to check left hand limit and right hand limit. So the left hand limit is limit x tends to 0 minus of f of x, that is equal to, we'll have to use this equation, limit x tends to 1 of x square minus 1, that is nothing but 0. So we have the right hand limit, limit x tends to 0 plus of f of x, that we'll have to use this equation, limit x tends to 0, so this is x tends to 1 plus limit x tends to 1 of minus x square minus 1. So we'll have the right hand limit as minus 2. So since LHL is not equal to RHL, limit x tends to 1 f of x doesn't exist. Question number 25. limit x tends to 0 f of x. This is what, given that f of x is mod x by x and 0 if x is not equal to 0, and this is if x is equal to 0. So we know that mod x is nothing but, it gives us plus x if x is greater than or equal to 0. It gives us minus x if x is less than 0. So again we'll find the left hand limit as well as the right hand limit. So the left hand limit is limit x tends to 0 minus of f of x. So we are approaching 0 from the negative side. So this can be written as limit h tending to 0 of f of 0 minus h. So since we know that this will be equal to modulus of h divided by minus h. So mod of minus h is nothing but plus h, that is h divided by minus h. We'll have limit here h tending to 0, limit h tending to 0, h and h gets cancelled. What is remaining here is minus 1. So right limit is limit x tends to 0 plus of f of x is equal to limit h tending to 0 of f of 0 plus h. So it means that we are approaching f of 0 from the right hand side of 0. So here the h is positive. Limit h tends to 0 of mod h divided by h, that is nothing but limit h tending to 0 of h by h, that is nothing but 1. So we know that LHL is not equal to RHL. Limit x tends to 0 of f of x does not exist. Limit x tends to 0 of f of x. This is what we have to find, given that f of x is x divided by mod x and 0 for x is not equal to 0 and x is equal to 0. Again we'll have left hand limit and right hand limit. Left hand limit is limit x tends to 0 minus of f of x is nothing but limit h tends to 0 of f of 0 minus h, that is equal to limit h tends to 0 h divided by mod of minus h, that is nothing but minus 1. So here minus h comes because h is a negative value. We are approaching 0 from the negative side. So right hand limit is nothing but limit x tends to 0 plus of f of x, that is nothing but limit h to 0 of f of 0 plus h. This is nothing but limit h tends to 0 of h divided by mod h, that is nothing but 1. Here also LHL is not equal to RHL. So limit x tends to 0 of f of x does not exist. So question number 27. So we have limit x tending to 5 of mod x minus 5. So since x is tending to a positive value, since if we approach phi either from the negative side or from the positive side, the function for mod x is nothing but x. Okay, so this doesn't make a difference. We can directly substitute the value of x here. So this is nothing but 5 minus 5, that is equal to 0. So next, question number 28. Limit. So they have given that limit extends to 1 of f of x is equal to f of 1. So f of x is defined as f of x is equal to a plus bx if x is less than 1. It is 4 if x is equal to 1, and b minus ax if x is greater than 1. So f of 1 is nothing but 4. So this is the question. What we have to find is the value of a and b. So if they have given that limit exists, it means that LHL will be equal to RHL. So let's find out what is the left hand limit of for the function, that is limit x tends to 1 of a plus bx. So we are approaching 1 from the left hand side. For the if x is less than 1, this would be the equation that we have to use. So fairly direct substitution, what we'll get is a plus b. So we also know that this, whatever the limit that we get, will be equal to limit x tends to 1 of f of x. So that value is nothing but 4. This is equation number 1. So we have right hand limit is nothing but limit x tends to 1 of, if we are approaching 1 from the right hand side, this will be the equation, b minus ax. Again, if we substitute x is equal to 1 here, we have b minus a is equal to 4. This will be equation 2. So if we solve these two equations, we'll get, if we add these two equations, a and a gets cancelled, we'll have 2b is equal to 4 plus 4 is 8. It implies that b is equal to 4. If we substitute the value of b in any one of this equation 1 or 2, we'll have a is equal to 0. So next question is 29. Limit x tends to a1 of f of x. This is what we have to find, given that f of x is equal to x minus a1 into x minus a2 and so on up to x minus an. So this limit will be equal to limit x tends to a1 of x minus a1 into x minus a2 and so on up to x minus an. So what we'll have is a1 minus a1 into a1 minus a2 and so on up to a1 minus an. So this will be equal to 0. The whole limit will be equal to 0. So the second sub question here is, we have to find limit x tends to a of f of x, where a is not equal to any of these coefficients, that is a1, a2 and so on up to an. So this limit will be equal to limit x tends to a of x minus a1 into x minus a2 and so on up to x minus an. That is equal to a minus a1 into a minus a2 and so on up to a minus an. Question number 30. So given that f of x is defined as mod x plus 1 for x less than 0, f of x is equal to 0 if x is equal to 0. F of x is mod x minus 1 if x is greater than 0. What we have to find is all the value of x where limit exists. This is the question. So let's try. Since we have two different equation at x greater than and less than 0, let's check whether the limit exists when the x tends to 0. So again we'll have left hand limit, that is limit x tends to 0 minus of f of x is nothing but limit x tends to 0. We'll have to use this equation mod x plus 1. So this is nothing but 1. So right hand limit is nothing but limit x tends to 0 plus of f of x. So what we'll have to use is this equation. So that is limit x tends to 0 of mod x minus 1. So this is nothing but minus 1. So limit x tends to 0 of f of x does not exist. So this implies that the limit exists everywhere except 0, that is r not including 0. Question number 31. If limit, given that limit x tends to 1 of f of x minus 2 divided by x square minus 1 is equal to pi. This is given. What we have to find is limit x tends to 1 of f of x is equal to 0. So we can split this limit in for numerator and denominator separately. That will be equal to limit x tends to 1 of f of x minus 2 whole divided by limit x tends to 1 of x square minus 1 is equal to pi. So if we send the denominator to the right hand side, we'll have limit x tends to 1 of f of x minus 2 is equal to limit x tends to 1 of x square minus 1 into pi. So if we substitute here, 1 minus 1 will be 0. So what we have here is limit x tends to 1 of f of x minus 2 is equal to 0. So this is nothing but limit does not apply to any number. So this can be sent to the right hand side. What we have is limit x tends to 1 of f of x is equal to 2. Question number 32. Given that f of x is equal to x square n if x is less than 0, and x plus m if 0 less than or equal to x and less than or equal to 1, and n x cube plus m if x is greater than 1. So they've also given that limit x tends to 0 of f of x exists. So we have to find what will be the values of m and n. So if this exists, it means that left hand limit and right will be equal to the right hand limit when x is tending to 0. Nothing but left hand limit is x tends to 0 minus of f of x So we'll have to use this equation, that is nothing but limit x tends to 0 of m x square plus n. So if we substitute x is equal to 0, the left hand limit is equal to n. So for the right hand limit x tends to 0 plus of f of x is nothing but limit x tends to 0. We'll have to use this equation. So it is approaching 0 from right hand side, that is nx plus m. So if we substitute x is equal to 0, we'll have m. Since LHL is equal to RHL, it gives that m is equal to n. Okay, so if we have to find the limit at as x tends to 1 of f of x, what will we get? The left hand limit is x tends to 1 from the negative of f of x is nothing but limit x tends to 1. I have to use the second equation, that is nx plus m. So if x is equal to 1, the left hand limit is n plus m, and the right hand limit is limit x tends to 1 plus of f of x is nothing but limit x tends to 1 of, we'll have to use the third equation, that is n x cube plus m. If we substitute x equal to 1, what we'll have is n plus m. So LHL is equal to RHL. This implies limit x tends to 1 of f of x exists. This implies m and n can take any value.